Hello, my people. Today we are going to continue with lesson number 2, and we are going to learn many things about cryptocurrencies and encryption, and also about decentralized identity management, cryptocurrencies and encryption. If you've been waiting to find out which encryption algorithm is used in Bitcoin, we're sorry to disappoint you. There is no encryption in Bitcoin, because nothing needs to be encrypted, as we'll see. Encryption is one of many options in modern cryptography. Committing schemes are just one of the many types, involve hiding information in some way, but they are distinct from encryption. A consequence of treating public keys as identities is that you can make a new identity whenever you want. You simply create a new fresh key pair. Public keys are usually used as a form of identity verification. However, scan P via the generateKeys operation in our digital signature scheme. This P is the new public identity that you can use. ENC is the corresponding secret key that only you know and that lets you speak on behalf of the identity P. In practice, you may use the hash of P as your identity, since public keys are large. If you do that, then to verify that a message comes from your identity, one will have to check that 1 P indeed hashes to your identity, and 2, the message verifies under public key PAKE. Moreover, by default, your public key PAKE will basically look random, and nobody will be able to uncover your real-world identity by examining Pay. Of course, once you start making statements using this identity, these statements may leak information that allows others to connect Pay to your real-world identity. We discuss this in more detail shortly. The idea of creating an online persona might seem like a harmless act. However, when people create a new identity, they are faced with decisions that can lead to some serious consequences. Using this identity in public places or posting about your personal life can easily expose your true identity. You can generate a fresh identity that looks random, like a face in the crowd, and is controlled only by you. Decentralized identity management. This brings us to the idea of decentralized identity management. Rather than having a central authority for registering users in a system, you can register as a user by yourself. You don't need to be issued a username, nor do you need to inform someone that you're going to be using a particular name. If you want a new identity, you can just generate one at any time, and you can create as many as you want. If you prefer to be known by 5 different names, no problem. Just make 5 identities. If you want to be somewhat anonymous for a while, you can create a new identity, use it for just a little while, and then throw it away. All these things are possible with decentralized identity management, and this is the way Bitcoin, in fact, handles identity. These identities are called addresses, in Bitcoin jargon, security and randomness. The idea that you can generate an identity without a centralized authority may seem counterintuitive. After all, if someone else gets lucky and generates the same key as you, can't they steal your Bitcoins? The answer is that the probability of someone else generating the same 256-bit key as you is so small that we don't have to worry about it in practice. For all intents and purposes, we are guaranteed that it will never happen. More generally, in contrast to beginners' intuition that probabilistic systems are unpredictable and hard to reason about, often the opposite is true. The theory of statistics allows us to precisely quantify the chances of events we're interested in and to make confident assertions about the behavior of such systems. But there's a subtlety. The probabilistic guarantee is true only when keys are generated at random. The generation of randomness is often a weak point in real systems. If 2 computers use the same source of randomness or use predictable randomness, then the theoretical guarantees no longer apply. So to ensure that practical guarantees match the theoretical ones, it is crucial to use a good source of randomness when generating keys. At first glance, it may seem that decentralized identity management leads to great anonymity and privacy. After all, you can create a random-looking identity all by yourself without telling anyone your real-world identity. But it's not that simple. Over time, the identity that you create makes a series of statements. People see these statements and know that whoever owns this identity has done a certain series of actions. They can start to connect the dots, using this series of actions to make inferences about your real-world identity. An observer can link together these observations over time and make inferences that lead to. In other words, in Bitcoin, You don't need to explicitly register or reveal your real-world identity, but the pattern of your behavior might itself be identifying. This is the fundamental privacy question in a cryptocurrency like Bitcoin, and indeed will. Thank you for watching. See you in the next lesson.